Homework question 11.3 asks us to rank these molecules in order of increasing water solubility. I think the first really important thing to think about is this rule of thumb that we have, and that is that like dissolves like. This means that polar things will dissolve polar things, nonpolar things will dissolve nonpolar things. So what we have to do right here is figure out, is water polar or nonpolar? This oxygen is more electronegative than the hydrogen, so we'll be pulling electron density away from the hydrogens towards the oxygen. That makes the hydrogens partially positive and the oxygen partially negative, and there's an overall dipole moment pointing towards the oxygen. This tells us that water is very polar. And one other thing we can deduce is that because we have some sort of H bond, water can engage in hydrogen bonding. So since water is polar, it will dissolve other polar things. Because we have this really strong partially negative charge and these really strong partially positive charges, it likes to be around things that are as charged as possible. So what we're really trying to accomplish here is to make a scale where on the left side we have things that are the least water soluble. These will be nonpolar, and then the scale goes all the way up to most soluble. And these are polar things. Looking at this first one, we see that it has an oxygen bound to two carbons. Oxygen is more electronegative than carbon, making it partially negative, and making these carbons partially positive. Because we have this partially negative oxygen, it can hydrogen bond with water because this hydrogen is partially positive, this oxygen is partially negative, and they can interact. So this is polar, and it can hydrogen bond with water. This next species right here is comprised of 1, 2, 3, 4, 5 carbons and hydrogens on all of those carbons. So this is something that we call a hydrocarbon because it's comprised only of hydrogen and carbon. And these tend to be nonpolar because there's no really electronegative atom that's pulling electron density away from another one. This next one, we see that we have a nitrogen bound to two carbons and a hydrogen. The electron density pulled towards this nitrogen from the carbons, as well as from this hydrogen, leaving it very partially negative. This hydrogen will be very partially positive. This will be a polar molecule. We have this very partially negative nitrogen that can interact with one of the partially positive hydrogens on water. So we see an H bond here. We also see, however, that this species has a very partially positive hydrogen. So this hydrogen right here can interact with the oxygen on water to form another hydrogen bond. Next, while we do have that typical pull of electron density away from the central carbon toward these two oxygens, that leads to this being a polar molecule. But one thing that should jump out at us is the fact that this is also ionic, because we see a non-metal here, this oxygen, interacting with this metal, sodium. This ionic bond leads to actual charges that would be stabilized very well in water. And so we'll note that it's ionic, which gives it even more charge character than something that's polar. Lastly, we see that there's electron density pulled away from this carbon towards this oxygen, from this carbon to this oxygen, and also to this oxygen. This one being partially negative, this is a partially positive carbon, partially negative oxygen, partially positive carbon, which makes this a very polar molecule. We can see two different areas here where a partially positive hydrogen could interact from water. So first, a partially positive hydrogen from water could interact with this partially negative oxygen to form a hydrogen bond, and then a partially positive hydrogen interact with this partially negative oxygen to form a hydrogen bond. So not only is it polar, but it can engage in hydrogen bonding with water. Now it's time to look at all the notes we've taken on each of these molecules and their polarities and rank them on this scale. The first most clear thing, I think, is that this non-polar molecule should be very insoluble in water. And so I'm going to place this one as the least soluble, number 1. Conversely, the more charged things tend to be more soluble. This ionic compound definitely has the most charge because these aren't just partially negative and partially positive, it's a true negative and true positive charge. Our most soluble species should be our ionic one. From here, we're comparing this polar species with this one and this one. This nitrogen species and this oxygen one down here at the bottom both have the ability to hydrogen bond two different ways. But this one up top can form a hydrogen bond with water, but not as many as the other two. And so for that reason, I'm going to make this one less soluble than the others and make it number 2. So now we're stuck trying to decide which one of these two molecules is the third most soluble and which one's the fourth most soluble. The best way to approach this is to try to determine which one of the two has the most polar bond. A more polar bond will make each atom in the bond more partially positive and more partially negative, respectively. And so having those large partially positive and partially negative interactions with the water is very favorable. So our course of action here is to look at these two molecules and determine which has the most polar bond within it, because having more partially positive and partially negative character makes a compound more soluble in water. The bonds that we can compare for this molecule, we have carbon-nitrogen bonds, and we have a nitrogen-hydrogen bond. In this molecule, the only types of bonds we have are carbon-oxygen. So this carbon-nitrogen bond that we see here first, if we look at the periodic table, we see that they're right next to each other. And so while there will be a difference in electronegativity for sure, it won't be as large as maybe some other bonds that we're looking at. For instance, this CO bond will have a larger electronegativity difference because they're further apart. In comparison, the nitrogen-hydrogen bond, they both have a very different electronegativity value. And so between these two molecules, this will be our most polar bond. It will be the more soluble of the two.